Hi, in this video we will remember how to calculate the gradient with a formula. So basically, when you have a line with some steepness, you can calculate the gradient. So this line is steep, this is, let's say, less steep, and this is more steep, right? But less and more is not enough, so we have to quantify the steepness itself. So that's where we talk about the gradient, which is also called as slope. So let's see what we're doing. So the gradient is the measure of the change in x and y, right? This is the change in x, and let's say this is the change in y, right? And we write the gradient, which is m, we denote it by m, as the change in y compared to the change in x, which I show with a delta to refer to the change. So it is delta y over delta x as a change in y over change in x. Now, how can we calculate the change in y and the change in x? What happens is we're going to choose, let's say, 2 points. Let's say this is the point A with coordinates x1 and y1, right? And this is the point B with coordinates x2, y2, right? So we are going to calculate the change by finding the difference between those coordinates, right? Let's see how. Right, the question says find the gradient of the line that passes through the points A and B with the coordinates given. Now, to find the gradient of this line, I have to find the change in y and compare it to the change in x. That also I need to find. So we know that this is the x value, this is the y value, right? So I'm going to find the difference in y values and write as a change in y. So it's going to be 11 minus 2. And for the change in x, it's going to be 4 minus 1. And I'm going to end up with 11 minus 2 is 9. 4 minus 1 is 3. So the gradient is 3. Now, there are a few things that you have to be careful of. First, you have to consider y values and x values separately. So you're finding the change in y, so you take away one y value from the other. And it's the same for x. Second, it's always y at the top, x at the bottom. It's just exactly the opposite of the alphabet. All right, that's how you can remember this. Because if you flip it, if you write change in x over change in y, that's not going to be the gradient, right? And basically that's going to be nothing. And next, now I went up with 11 minus 2, choosing, this value first and taking away 2. So if I'm choosing the first value to be a coordinate of b, then I should choose the x coordinate of b first, which I did, right? I started with 4 first. And, well, you may ask whether you could flip the numbers. Yes, you could write 2 minus 11, which is fine, but then you have to write 1 minus 4, not 4 minus 1. Because the order is important. If you're starting with the coordinates of A, you have to go on with the coordinates of A, and vice versa. And in that case, let's go on with the calculation. 2 minus 11 is minus 9, and 1 minus 4 is minus 3, so we still end up with the same gradient. So as long as you do the calculations correctly, it doesn't matter which coordinates you start with. In this example, we are given a line graph and we are asked to find the gradient. Well, all we need is the coordinates of 2 points on the line, so we can pick any 2 points we'd like. For example, the point A, let's say, has coordinates minus 1, 2, 6, right? Right, properly, 6. And let's say the point B as coordinates 3 to 0, right? So if I have the coordinates of A to be -1 to 6 and B to be 3 to 0, then I can just calculate my m, the gradient for this line, as 6 minus 0 over -1 minus 3, which would be 6 over -4. Then I'm going to end up simplifying this to be minus 3 over 2. If I flip the numbers, I will still have the same gradient. So if I go like 0 minus 6, then I'll go like 3 minus -1. This is very important. This negative sign belongs to 1, and this is the subtraction. So please do not forget to use both of them. Otherwise, the sign will be different and wrong. So it's going to be minus 6 over 4, which will again simplify to minus 3 over 2. Before moving on, note that if you are given a graph, then you can pick any 2 points on the graph you'd like. These are my choices. You could end up with 2 other points, but you will still end up with the same gradient if you do the correct expression solutions. Right. Another example. Right, in this example it says show that these 3 points are collinear. First of all, collinear means being on the same line. So basically we are asked to show whether these 2 points, right, well, -2 to -7 will be somewhere here, 1 to -1 will be somewhere here, and 4 to 5 will be somewhere here. We are asked to find whether they lie on the same point or not. Well, the only way to show this is to calculate gradients, right? So first, I'm going to pick these 2 points. It doesn't matter which 2 you pick, but I just chose these. I'm going to calculate the gradient for these 2. So m is equal to 2. So, if there's a line passing through these 2 points, its gradient would be 2. Now, what if we have another line that passes from these 2 points? Let's calculate its gradient. So when you do the calculation, you'll see that the gradient is again 2. This tells you that the line passing through these 2 points is parallel to the line passing through these 2 points. But just because this is their intersection point, you can consider that these 3 points are collinear. You could have picked the first one here and the last one and the first one and the middle one, and then you would still end up with the same gradient, right? As long as you end up with the same gradients in these 2 calculations, it shows that these points are collinear. Hence, choosing any 2 points out of 3 and calculating the gradient and doing it twice to show that the gradients are the same is enough to show that these 3 points are collinear. Right, it's exercise time. There are 3 questions here for you to solve on your books and submit their answers online. Thanks for watching.